Okay, we might get started. Hello, everyone. Thank you for joining us today. For those of you who are not familiar with Nortek in the past, we are an oceanographic instrumentation company headquartered in Norway, just outside of Oslo, with offices around the world. Our primary products are acoustic sensors used to measure water velocities underwater. My name is Harry Hughes, sales engineer at Nortek Australia, and I'll be your host today. Before I introduce our presenters, I'll briefly speak about how we will run this session. I'm sure many of you are at least recently become more familiar with Zoom meetings. Can I ask that everyone take a moment to ensure that your audio is set to mute? You'll find your audio controls towards the lower left corner of your screen. Please feel free to have your video on or off, but we'd love to see your faces. Please click on both the participant and chat buttons at the bottom of your screen to expand these windows. Following the presentation, we will open the floor up to questions or comments. If you wish to ask a question anonymously, please type it into the chat and select the option at the bottom of the chat window to only send this private to the host. I'll read your question aloud to the presenter without mentioning your name. You may also use this window to ask questions should you be experiencing trouble with your audio. We also welcome you to ask questions aloud. Please find the raise hand option in your participant window. We will call on you if your hand is raised, so you will unmute yourself. You can ask the question. Participants who raise their hands will be listed in the order in which they do so, and we will call on you in that order. Our presenters today are Tom Christian Moston and Ulrik Blomseth. Tom has a degree in environmental engineering and has been with Nortek since 2007. He's an experienced field specialist and has deployed oceanographic equipment all over the world. Prior to joining Nortek, he worked at the Norwegian Institute of Water Research, known as NIVA. Tom Christian is happiest when he's out in the field, helping customers stay out of trouble to achieve their measurement goals. We also have Ulrik Blomseth, who joined us last week for his webinar on troubleshooting. Ulrik is a recent graduate mechanical engineer from the Oslo Metropolitan University. He is part of the Nortek support team and helps users with technical questions related to ADCPs. So without further ado, thank you, Tom and Ulrik.
Thank you, Harry, and thank you everyone for tuning in to this webinar. Tom Christian and I are part of the Nortek support team, and every day we are helping users from all around the world with technical and practical queries related to the Nortek instruments. We have a lot of technical documentation and other useful information available. You can find this on our website, and you can visit our support center. Here you'll find a series of links to manuals and quick guides and frequently asked questions. I highly recommend everyone taking a look at these before starting to use their instruments. You can find papers and technical notes. See, also there is a section with support videos where you can find old webinar videos and how-to videos. And in the community forum, you can admit support questions. So if you have any questions after this presentation that have not been answered, feel free to go in here and post your questions, and one of our technical experts will try and help you soon. See, yeah. So thanks, and I'll hand the presentation over to Tom Christian now.
Thank you, Ulrik. Hello, everybody. We're going to talk about how to prepare to a field ADCP field deployment, and in lack of another analogy, this is just like baking a cake. Actually, it's you have a lot of ingredients going into a recipe, and in the end, you want to have a beautiful, delicious cake. It's more the same in by deploying ADCPs. You have a lot of things going into this recipe, and in the end you want to have good data actually. And this might be kind of for some of your listeners, this might be really obvious, but I have to say that each week we get a lot of data coming in from our customers around the world. And what I see in these data is that a lot of things are lacking in the preparation and the the deployment phase of deploying ADCPs. So we're just going to talk a little bit about what we do when we are testing instruments or helping out customers in the field. So the first thing I do is I have this project coming in to my desk, and I read that scope and try to understand what's going to also what we're going to do. And the first thing I do is to go make a desktop survey. I go into the digital maps I have available and understand what kind of bathymetry we have, what kind of depth we have, all these kind of things I do before I start designing anything else. So the map you see on the right side here, this is something I deployed for 4 weeks ago. It's 10 instruments standing at the depth down to 400 meters. It's on the west coast of Norway. So this is basically the first thing I do before I go out and to the field. Eirik, further on. Next. Eirik. There you go. Okay. Yeah. Oops, sorry. The second thing I do after I have made a desktop survey is to decide on what kind of instruments I have or we're going to use in this. Is it going to be a wave measurement I'm going to perform? Is it going to be a deep water deployment? Do I need to have a profiler instrument? And as you see, we have a lot of different instruments for different tasks in Norway, now in Nortek. The second thing I do is to understand what, after I've chosen what kind of instruments I'm going to use, I decide on what kind of frames or subsurface buoys or tripods or whatever I'm going to use. For each project, you might need a bottom frame, for instance. If it's a troll activity, you need a tripod that are resistant for trolling activities, like the one we have with an AVAC there. And other things I do consider when I are deciding on which kind of frame I'm going to use or subsurface buoy I'm going to use is what kind of materials are close to the instruments. If you see the tripod on the right side here, the red one, this is a project that didn't go that well actually, because they have added yacht anchors for down weight on this frame, and of course we had a compass declination of 45 degrees actually on this one. So please remember to make sure that you don't have iron or other magnetic materials close to the instrument, because that will give you a compass deviation. This is also really important, and we see this unfortunately a lot of the data coming into us in the support. Next thing is designing the installation or the mooring. I always do make a drawing for just to see that all the bits and pieces are there. And I also do use this mooring for this drawing of the array, the deployment array, to have on board the boat or the vessel I'm going to use. It's easier to actually show a drawing of how this equipment is going to look like when you have deployed it for the crew and for the safety and everything. And so I always do that. And it's also nice to have in the final report with the data, because then people can understand easily how this has been standing in the water. Other things we do see in especially with profilers is that people are forgetting side lobe interference. So because of the surface, when the instrument is hitting the surface, we have side lobe problems. And that's something you have to remember, and don't use the data close to the surface. Other things we do see is multiple instruments are pinging at the same time. And this is also a problem we do see a lot, that you are actually, like the drawing you have here, you have like a signature 100 standing at the 300 meters depth. And of course, the signals from that one will travel all the way up to the surface. And if you start the signature 500 at the 50 meters depth there, the signature 500 will pick up the signal for a signature 100. So in order to make sure that the instruments are not listening or are making trouble for each other, you have to stagger them in time. So for instance, if you're gonna measure, also start the signature 100 at 12 o'clock, and it's gonna be measuring for 60 seconds, for instance, then you have to start the signature 500 on the top there for 12:01, for instance. Another thing we do see is that people are losing instruments, unfortunately, and a lot of things coming into us attached to a frame. For instance, we see people are mixing metals, for instance, stainless steel against shackles that are galvanized, for instance, and this will corrode away. So please do remember, never mix metals. And if you have to mix metals, be sure to isolate them from each other by using bushings, nylon bushings and things like that. Other problem we do also see is that transducers are hitting something in the water. So make sure to have an obscured sight into the water column. If I'm going out to the North Sea, I usually use mooring design and the dynamics. That's free software that are using MATLAB. So that's an easy program to test your mooring design in terms of drag down and things like that. Another problem we also see is that, like long moorings for the instance like this, would we have 260 meter mooring line, that people are using too thick, also the rope is too thick. I usually go for Dynamo rope, 6 millimeters I use, but I do see a lot of people are using like 12 millimeters of rope, and then you have, if there's a lot of current in the area or on the deployment site, you will experience drag down. So this is also something to be aware of. Before you go into the field, and for trouble-free deployments, make an instrument checklist. This can be, you can download it from our web support site, or you can make your own. And it should be covering like, do I have the latest firmware and software update? You have to have a functionality test based on that. You see that the pressure, tilt sensor, compass is working properly, and the transducer are giving are not damaged. New batteries pack is connected. Battery memory space requirements are met. If you are deploying an instrument and you do want to have you are measuring to, or do you actually when you configuring the instrument, that all these kind of memories and everything is actually allowed to do it. If you try to do something that the instrument is not able to do, you will always get a warning. But it's nice to have this in the instrument checklist. Pressure offset, I do see that people are putting out the instrument and a pressure offset of 10 meters, for instance, is present. So do calibrate the pressure before you go into the field. Compass calibration is also an important thing. Try to, if you are using a tripod or a buoy with metals inside, please try to make a compass calibration before you go in the field. And also insert dummy plugs. We do see people are not inserting the dummy plugs, and eventually the instrument will leak. Before I go into the field, I always make sure that I have a packing list of everything, because it's kind of, you're going to travel often, for me at least. It's going to be a long way to the field and you're far out to sea. So if you haven't made sure that you have everything that you need for the deployment, it's going to be costly. We do see people are going out there and have, for instance, forget to take the deployment or the communication cable with them, and that's when you are 3 hours away from shore on a vessel. Then you are kind of stuck out there and you have to go back, and that's it's a costly time, vessel time and hire and everything. We're not going to cover all the techniques of deploying things. I think that's going to be a different session. But after all this, then it's just putting the instrument into the water like this. Another thing is maintenance. We do see instruments from time to come coming into Nortek in Norway for service purposes, and they are been cleaned with steel brushes and sponges with hard surfaces. Please don't do that. If you have like are experienced with a lot of biofouling, I usually go for vinegar, 50-50 of vinegar in a bucket with water, and just place it there for like 1 or 2 days, and it will be really easy to clean up. We do have also patches for the transducer right now available on our web shop that will help the instrument, as you see on the picture right down there, will help for reducing biofouling. So that was it. Connector care. This is also really important. Remove flush with water and remove dirt and let it dry. Inspect for damage, corrosion. If you for some reason do see corrosion on dummy plugs, please, then you have to change the bulkhead of the instrument, because then the dummy plug and the connector are damaged, and eventually the instrument will leak. So whenever you see corrosion on a dummy plug, like you see on the picture here, you do need to send the instrument in for replace the underwater bulkhead. And that's it. Thank you. Questions?
Great. Thank you very much, Tom. We have got no questions just at this stage, but we'll give people a chance to fire off any last-minute questions they might have.
Mm-hmm.
I guess just while we wait for others, I'll just have one of my own. And the field, Tom, what is one of the more common mistakes that you have made in the past?
My common fails. Well,
maybe none.
Maybe none.
I myself have definitely made a mistake with the dummy plug, not putting that in.
Yeah.
So,
Well, I have to say that of course during like the last 20 years I've done, as I learned from my own errors, of course. And yeah, I have, in a hectic period on an offshore vessel, I had forgot one dummy plug. It went well, but I have done that before. And of course, like stagging instruments in time, yes, I've learned that from my own experience, that you get this fine pattern when you're coming back, looking at the data, and you're just like, what is going on here? So stagging instruments, and I see that also with the, especially with our signature series, that because it's a broadband system, so like a 55 will kick in on a back-to-back installation of a signature 100 and a 55 on top. I see it there as well. So it's really important to stag instruments in time when you have them close to or installed in a close area, close by.
yeah, understood. We've just got a few questions coming in, Tom. The first one is from Anup. It was like, hi, Tom. Could you give more detail on the patches you mentioned for biofouling protection, how to apply them, and what degree of protection they give?
Well, this is something, these patches are a film that will protect, that are made especially for our, or the sizes for our transducers. They will increase the, how to say, the, or increase the biofouling by, I think, 3 times the normal. So if you put like say you have an AVAC standing on 25 meters of the water depth, you should have it will be possible to have it out 3 times longer than a normal in AVAC. We have it on the web shop, and it's yeah, it's described with a video on how to deploy them onto the instruments, and and they do work, they do that. They are costly though, but yeah. You will find them on the web shop. I think we can send the link to that to the one that needed the question.
Yep, no, thank you, Tom. Yep, I will. I'll send that link because there is a bit of detail. I think there's an article on the website in regards to anti-fouling and the patches, and a comparison made from using the patches as well as not using the patches. So thank you, Anoop. I will send you that link. Another thing that I like to do sometimes is to use duct tape or bagging the instrument along the sort of the battery canisters as well. It doesn't really affect anything to do with the recording, but it will avoid a messy cleanup at the end of the day, just ripping the bag off.
Yeah.
We have another question. We just had a customer send an instrument that has leaked due to excessive O-ring grease. Can you please explain grease application for both O-rings and connectors?
Well, what I do on especially what I use in the field when I'm having the connectors, I use silicone spray to make sure that the connectors are not that the rubber is not dry, so it comes in. I do not fill up with silicone, with silicone grease inside the underwater connectors. I use silicone spray. And for the O-rings in the instrument, I use silicone grease, but not a lot. It should be just a thin layer of it, not like extensive that how to say, like you can see lumps of silicone. It should be just like a thin film, and it should be you should see it as but I've seen, like for the bulkheads, I've seen people are using a lot of silicone grease inside, and I don't use that. I use silicone spray for the connectors.
Okay, great, thank you. We have a question from Jack Teo. Trolling is very frequent in my area. Any suggestions on how to ensure a successful measurement despite this?
Well, when I do test in Oslofjord, I do try to find out who's going to fish there and try to talk to them and say, like, I have a project going on here. Is it possible to me to put down equipment down there so they can troll around it at least? There are bottom frames, for instance, huge bottom frames, for instance, from deep water buoyancy that are troll resistant. So they are really flat, but they are really big. But I think a troll should just bump over it. It shouldn't take the whole thing inside the troll net. It should just bump over it. But these are big, so there are possibilities there. But then you need a big vessel with a big crane and things like that to deploy the whole thing. But if you go into the website of deep water buoyancy, you can see like troll resistant bottom frames. But if you're going to have like an array of instruments going up into the water column, yeah, well, that doesn't really go really good with trolling activities, actually.
Yeah, it's always a difficult one because sometimes the fisheries don't know about all the boats that are out there as well.
Yeah.
Jack has got an extension to his question. He also said, and I wonder if you ever had a deployment that is not fully upright. So I'm guessing this is beyond the gimbal correction. I've come across a bad measurement data like this previously and had to do some analysis from the bad data. Do you have any experience or any suggestions for this situation of having an instrument that is recording but on a tilt, I guess, greater than the required tilt?
For a profiler, if you go exceed the maximum tilt of 30 degrees, then you go into the map vertical problem. 30 degrees is kind of, I'm not, so one of the beams are then measuring more or less horizontal because you have 30 and then 25 again. No, I think we have to come back to that. I haven't used data from an instrument that's tilted that much. We basically say that you have to do this on one more time. You might go in and see if the beams, beam 1 and 2, if you can process on the beams that are pointing more upwards. You take away the one that's are most vertical and try to see if there are any possibilities to just process data from beam 1 and 2 if they are pointing upwards. That might be a solution for it. But basically, you will have a problem with that.
Yeah, no worries. I will follow up with Jack after this one on that one.
Yeah.
We have another question. Which instrument is better for waves, the AWAC or a signature 500 or 1000?
Well, like for the process is the same. But for current measurement, you will have the possibility of having more accurate current measurements because of the broadband system of the signature series. Another thing we do see, that the fish farming industry in Norway are using more and more signature 500 because now they are able to measure waves and current at the same time, and has been a problem with the AWAC because you are not able to measure waves and current at the same time. And then they are able to fulfill the requirements from the government. So that's kind of one of the largest difference between those two, the AWAC and signature, that you are able to actually have measurements of current at the same time as you measure the waves. I should point out, yeah.
Yep, definitely, yeah. And as you mentioned, Tom, it's got a much more advanced tech package and board with it as well.
Yeah.
Great, thank you. We have a question here. How do you determine what frequency you will use in your deployment?
That depends on what I'm going to do. So, for instance, if I'm gonna like profile, like say 70 meters, I use a standard Aquadop 400. But if I'm gonna, so it's dependent on the range actually what I'm going to do. If, for instance, in the deployment I did on the West Coast 4 weeks ago, I had a mix of instruments depending on the depth at the deployment site. So I have like 3 signature 100 are going to measure 300 meters each, and then on top of that I had a signature 500 that's going to take the last 50 meters to the surface in order to come as close to the surface as well as possible. And the other places I had two signature 250 that's going to take 200 meters, and on top of that I had signature 500 as well to take this last 50 meters. So it depends on what you're going to do, and of course the accuracy of the measurements is when you have a high frequency like a 1 megahertz instrument, you're able to have the standard deviation, a better standard deviation than a 400 kilohertz. So yeah, it depends on what you're actually gonna measure. Yeah.
Okay, great. We have another question here. Where is the mooring planning software available, and does it have any manuals?
Yes, you just have to. I think we can send the link out, but you find it's a free software and it's well documented and it's been out there for decades. But you have to have a MATLAB license to run it. And as I said on the web page, if you go into the mooring design. It's well documented how to use it. I do know that Deep Water Buoyancy do have a software that you can buy in order to make a mooring design, because the mooring design on that's free on the website or on the internet is kind of old, and it's not been that well. So it not happened anything on the last 10 years, I think, on that one. Okay. But I think we can send a link to the one that asked for that one.
Okay, no problem. Okay, I think that is it for questions. I don't see any more. Thank you for your time, Tom. Jack has responded that, yeah, I think he has tried to use the upright beams as much as he can. But I'll follow up with that one for those erroneous measurements.
Yeah.
I think that's it for today. Thank you again, Tom and Ulrich. Some very useful tips there in the field. There's nothing worse than going out and then coming back a few months later to find that there's an issue. No. So thank you for your time, Tom and Ulrich.